Hi everyone, I am Parimala M. Nair and I am pursuing BTech in Biotechnology in the Vellore Institute of Technology. Today I have this video for all of you on the special theory of relativity. Hope you all enjoy it. This special theory of relativity was formulated by one of the greatest scientists that the world has ever seen, Dr. Albert Einstein. It was formulated in the year 1905 and discussed widely in one of his famous papers on the electrodynamics of the moving objects. There are two postulates under this theory. The first one, the laws of physics are invariant in all inertial systems. The second one, the speed of light in vacuum is same for all observers regardless of the motion of the source. Now let's discuss the first postulate. Consider you are in an aeroplane and you are running across the aisle. Does that feel any different from running in a garden? Though the aeroplane is traveling at a very high speed, you don't feel much difference. This is because in relation to the aeroplane, you are stationary, and in this case, the aeroplane becomes the frame of reference. As the aeroplane is the frame of reference and the laws of physics would be the same for all inertial systems, you would not feel any difference and you would just feel as though you are running in a garden. Now let's move on to the next postulate and try to understand it using an example. Consider a car is moving and you are observing the motion of the car. Suddenly, the person sitting inside the car switches on the light. The speed of the light for the person inside the car would be 3 into 10 to the power 8 meters per second. But it would be very interesting to note that for you two who's observing the motion of the car, the speed of the light would be 3 into 10 to the power 8 and there would not be any difference. The second postulate was experimentally proved by two scientists, Michelson and Morley. The aim of their experiment was to measure motion of Earth through ether. Ether was believed to be a medium for transmitting light and heat. In Newtonian physics, all waves are to be propagated through a medium. Therefore, the Newtonian physicists postulated that ether is the medium which is used to transmit electromagnetic waves and it pervades all space. The Michelson and Morley experiment produced negative results, and the failure of their experiment led to two important conclusions. First, that ether does not exist, and the second, that the speed of light is same for all observers. Now, let's move on to a very interesting topic, time dilation. To explain time dilation, I could just say that moving clock ticks slower than a clock at rest. Consider a beam of light which is bouncing between two mirrors separated by a distance h. From this, we could write that 2 times h is equal to ct, where c is the speed of light and t is the time interval between two successive collisions at the same mirror. Now imagine this clock is fitted with a spacecraft which is moving at a very high speed v. The trajectory of the light beam would be as shown in the figure. From the figure, we can derive the following. R is equal to c times t dash by 2, where t dash is the time interval of the clock. L is equal to v times t dash by 2. From Pythagoras theorem, L square plus h square is equal to r square and h square is equal to r square minus L square. Now after substituting all the values that we have, we get t dash is equal to t by root of 1 minus v by c the whole square. So this is the equation of time dilation. Repeating myself, t dash is equal to t by root of 1 minus v by c square, where t dash is the time interval of the clock which is in relative motion with respect to the observer and t is the time interval of the clock which is at rest with respect to the observer. From the equation, it is clear that When the speed of an object approaches the speed of light, the time interval of the clock approaches infinity, and therefore the clock would start ticking slower than usual. I hope this video has thrown some light on the topic of special theory of relativity, and I hope you found this video useful, and thank you for patiently listening.